Okay, let me continue giving you some more examples. How would you sketch this graph here? Y equals 1 over x plus x squared. Okay, so to do this here, you've got to ask yourself which. Actually, start by imagining a graph like this. Now, when x is small, just around this region here, which term will dominate? Will this term dominate, or will this term dominate? Which one would be bigger? Or well, anyway, let's choose something like 0. I don't know, 0.3. Well, when x is really small. So if we put 0.3 into here and 0.3 into here, which term will be more significant? Which term will be more relevant to what we're doing? So you're trying to plot y here. So let's put 0.3 in here. So 1 over 0.3 plus 0.3 squared. Okay, so which, well, this here would become, hang on, calculator, clear. So 1 divided by 0.3 equals 3, 3.33, say. And now 0.3, 0.3 times 0.3, so hang on, so clear, 0.3 times 0.3 equals 0.09. So here this term seems to be more dominant than this term here. Okay, so around 0.3 region, this term is slightly more dominant than this term. Let's make it really small. Let's make it really close to the y-axis. So let's choose 0.0004. Let's put this. So we are looking at a value where it's really close to the 0. Okay, so let's put that into this thing here. Okay, so we will have 1 over 0.0004 plus 0.0004 squared. Okay, so this here, the y value here will become, hang on, calculator, clear. So we are doing 0.1 divided by 0.0004 equals 2,500. Okay, now do 0.0004 squared. So wait there, clear this. So it would be 0.0004 squared. I can't find my squared button, so I'm just going to times by itself. 0.0004 equals, well, hang on, 0.246, hang on, 1, 2, 3, 4, 5, 6, 1, 6. Okay, yeah. So when x is really close to when x is really close to the y-axis, you can see here this term here is so much bigger than this term here. So when x is small, this 1 over x here is so much more dominant than x squared. Look at x squared. We can pretty much forget about this. This is nothing. But look at this. This is significant. This is relevant to what we're talking about. This is significant. So when x is small, this thing here will be significant. This thing here would be more important than this thing here. And you can use the same technique and do it for minus 0.0004. And well, hang on, let's start again. So y equals 1 over x plus x squared. You see, when x is small, this term here is very important. This here, we can pretty much forget about it. So when x is small, the graph will want to follow this personality, if you like. So it wants to do this. Okay, so when x is small, it will adopt this personality. Now when x is big, if you choose 9999 and put it into here and into here, well, this number here, when x is big, probably around here somewhere and around here, this term here dominates. So it wants to do this. So when x is big, it wants to do this. Hang on, It wants to follow the x squared curve. Okay, the x squared. But because we don't really care about the middle and when x is small. When x is small, it's going to adopt this. It will adopt to 1 over x. So when x is small, we can forget about this. It's only valid when x is big. Okay, so when around here, when x is big, it wants to follow this x squared. It wants to do this, the x squared thing here. Now, when x is small, it wants to do this, so it's going to follow this. So now it's just a matter of joining up the two now. So the graph here will look like this, and then over here it will look something like this. Okay, so hang on, let's start again. So y equals 1 over x plus x squared. Now to draw this graph here, do this here. When x is small, it wants to follow this. So let's quickly sketch this in. Oh, it doesn't go up, it goes down. Hang on. It's supposed to go down, okay? And when x is small, it wants to, when x is small, it wants to do that. Now, when x is big, it wants to do it wants to do this. It wants to follow this. But then, when x is small around here, it gets overtaken by this term here. So, well, anyway, when x is big, it wants to do this. Okay, around here, and it wants to do that. Now it's just in the middle here, we don't know what happens, so we're just going to guess, join them up. Hang on, so it looks like that, and then here again, here we don't know what happens, so we're just going to guess around something like that. And by the way, it's supposed to be a curve, so this here is supposed to be a curve. Okay, so we're going to guess our graph to look something like this. Now, find yourself a graph plotter on the internet, and it should look something like this. You see that? This is a graph of y equals 1 over x plus x squared. Now, you see, when x is small here, when x is small, it wants to do this. Okay, and when x is small, it wants to do this. And then you've got to combine it with this here. This is your x squared. The x squared. Hang on. The x squared here. Y equals 1 over x plus x squared here. The x squared is actually wanting to do this. Hang on. Ugly. Sorry. The x squared wants to do this. It wants to go through the origin like this. It wants to do that. That's what it wants to do. The x squared. But the minute it gets to around this region here, it will adopt this, and this here will look something like this. And then here it will look something like this down here. But then somewhere in between, in the middle somewhere, you just got to merge the two together. So overall, your y equals 1 over x plus x squared will look something like this. So if we didn't have this here, you could probably guess it roughly. You could guess it. When x is small, it wants to do this, and when x is big, it wants to follow the x squared. Okay. Now it's just a matter of joining up the two. So it does give you a rough idea of what the graph will look like. The true graph looks like this. Okay. So it does give us a good indication. Okay, in the next video I will give you some more examples.